We're now going into the last topic of Chapter 1, which completes our review of elementary algebra, although some of this stuff is challenging. We're going to now look at quadratic equations. Now, we had said earlier that an equation is to the first degree as long as the exponents on the variables were to the first degree. But here we see now the exponent on the variable is 2. So that is to the second degree. So this gives rise to what we see here as a quadratic expression in standard form, and then once we equal it to something, it becomes a quadratic equation in standard form. Now, the letter A in the equation is the numerical coefficient of x squared. The letter B in the equation is the numerical coefficient of x. And C is just that constant. Now, we had said earlier that if we put something in this form, we may be able to factor it. And that's what's going to lead us to one of the properties we'll get to in just a moment, the zero factor property. But here are some examples of quadratic equations. Notice the x is to the second power. Now, what is the zero factor property? I'll write it over here. A times B equals 0. Now, here we're multiplying A is then a factor, times B is a factor, and the product of that multiplication is going to be 0. Now, that's what the zero property or zero factor property is, which pretty much means in order for this statement to be true, either A or B has to be a 0. Because if A is 0, 0 times B equals 0. Anything times 0 is 0. Or if B is 0, 0 times A is 0. That's the only way that that can be true. Because if this were like 5 and this were negative 5, that wouldn't be 0. That would be negative 25. The only way this is true is if one of the factors are 0. Now, we're going to see as we get into this that we're going to take our trinomials that we did earlier and factor them and equal them to 0. So this factor equals 0, and this factor equals 0. And we'll go through the property, but again, put a big star by this because this is an important process here. Now, as we go to example 1, notice the form that it is in. We have a factor. In a sense, this could be our A, times another factor, which could be our B. And we're saying that series of factors equals 0. Well, once again, the only way that this could be true is if this factor, which is right here, equals 0, and this is the protocol of how to solve it, or if this factor equals 0. So we just transpose that. Negative 4 on this side, it becomes a 4. Here we transpose the 7. That becomes a negative 7. And then we have the 3 left that we will divide both sides by 3. And we get x equals a negative 7/3. Remember, we said the ideal place to write this negative sign was by the division bar. So these are your answers. Now if you put a 4 there, that makes this 0. If you put a negative 7/3 there, that makes this 0. And that would be the check. Now in example 2, this is the more typical type of equation you're going to get. So, how do you know it's quadratic? Well, it has to the second power here. So the first thing we do is we put it in standard form by transposing the 3 to the other side becomes a negative 3 on this side. Now, then we will factor this. Again, if there's any common factor, you would take that out first. And you factor it into its factors. Now, you take each of these factors and equal it to 0. This is what you want to show on your blue sheet when you take a test and in your homework log. So here we transpose the negative 1, divide by 3. There's our first answer. Here we transpose the 3 to the other side, becomes a negative 3, divide by 2, and there is your second answers. Now, both of these are solutions. If you put the 1/3 there, it makes this a 0. You put the negative 3/2 there, that makes this a 0. This is the principle of the 0 factor. All right, let's go on. Now, you may notice that we are getting 2 solutions. And the reason is that these are quadratic equations, and you should have an equal number of solutions that you have the degree of the variable. Now, another one that we're going to take a look at is this one. And I'll set it up here for you. X squared equals 5. Now in a previous chapter or section, we looked at this and we said to get what x is, we could take the square root of this. So that would be x. But what you do to one side, you have to do to the other. And here you would get the square root of 5. Now, interestingly, here we're only getting one solution, and we should get 2. Now, the recipe then for getting the 2 is that when we take the square root of something, we have to include that it could be a positive, or it could have been that negative solution. So our answer here is going to be a plus or minus, it's not showing up too well here, the square root of 5. And that's what they're showing you here. That's the square root property. So as we do 17, I'll write it out for you. So once again, it's when you take the square root of this side, you're going to do plus or minus the square root of the other side. That ensures that you get 2 solutions. So let's do example A. And they have these out, but I like to write them out a little bit. And that's pretty easy, that one. Let's do another. So when we see this second one now, let me set that up for you. Y minus 4, the quantity squared, equals 11. Well, we can use that same square root principle. We take the square root of this side. Remember, if that's raised to the second power, here we have an index number of 2, and that then becomes just the radicand. But remember, on this side, it's plus or minus the square root of 11. So our plus or minus square root of 11 is still there. And now we just transpose the 4, and we get y equals 4 plus or minus the square root of 11. Again, if it's in this binomial squared form, you just take the square root of both sides. And there's our answers. Now, we do have something that they're not showing us here, which is called completing the square. It's not featured, but I'll just show it to you briefly. Suppose we had the equation x squared plus 6x plus 2. Now, we know that's not going to factor. But in completing the square, we want to make, on this side, a perfect square trinomial. So, if we do, we have to replace this c term with something else. So we take our 2, move the 2 to the other side, and we get a negative 2 there. So this 2 now is gone. Now, in completing the square, if you recall that technique, we said x squared gives you this. A plus sign goes there, and we multiplied it by this term and then doubled it. So if our b term here is 6, when we doubled it, it got to be 6. How can we undo that? We'll take half of 6, which is 3. Now, in order to complete this square, we have to square the 3. This gives us a 9. We have to add 9 then to the other side to keep it an equation. So factoring this becomes a binomial squared, and then doing this gives us now a 7. So this is similar to what we had here, but this is a process, and they're not featuring it here, but is interesting. So we completed the square. We now take the square root of this side. We get x plus 3 equals plus or minus the square root of 7 now. And we just transpose the 3, and we get x equals negative 3 plus or minus the square root of 7. Now, if you take the quadratic formula here, or the quadratic equation, and use the principle of completing the square that I just showed very briefly, by taking the c term over to the other side, and then dividing everything by a, and then doing a number of steps, you end up solving for x. But you need to know values of a, values of b, and values of c to put into this formula to actually get a solution. So with that in mind, we go to our next page, and we take a look at the quadratic formula. Now, key to this, and this is super important, is the original equation must be in standard form. So let's write it over here. X squared. I have to transpose my 4x to the other side, where it now becomes a negative 4x plus 1, and that equals 0. So we have to put it in standard form. because now we have to identify our A term, which is the numerical coefficient of x squared, which will be a 1, our B term, which is a -4, and our C term, which is a +1. So you can't pick it out of this form. It has to be in standard form. And now we substitute into the quadratic equation, or quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. So x will equal, now our b term we said, let me just write it up here, a, b, and c. Our b term is a -4. So if we put a -4 there, we have the opposite of a -4, makes this a +4. Plus or minus, we're going to square the 4 and get 16 minus 4a. We said a is 1 times c. c is 1. And all of that is going to be over 2a, which is 2. So we then get x equals 4 plus or minus. Now this is going to be a -4, so this becomes plus or minus the square root of 12 over 2. But now the square root of 12 we know is actually, let me do it over here, the square root of 4 times the square root of 3. So what is the square root of 4? 2. So I'm going to rewrite that as 2 the square root of 3, because that's what 12 is, 2 the square root of 3. Now notice I can separate this if I like. I can put the 2 there and put it over common denominators, and notice what happens now. And I'll even change colors. This cancels out and we're left with a 2 there, and it's plus or minus, and these 2's cancel out as well, the square root of 3. And lo and behold, that's what they have. So again, your typical quadratic equation, if you're going to use the quadratic formula to solve it, you need to put it in standard form, so you identify the proper A, the proper B, the proper C values to put into the quadratic formula, and it takes a little practice. Here, if this were a if our B term was a +4, here it would end up as a -4. But since B is a -4, it's the opposite of B, which makes it a positive. Here it's always going to be positive because you're squaring it, and then just carefully substituting to get this. And we do get 2 solutions, and that's what you would have to write in MATLAB. Let's go on. Now you could put this into your calculator and get numerical values which are approximation. They often want you to round to 3 decimal places. So as we look at this one, the 4th place, if it was 4 and below, we drop it. So we drop it. If it were a 5, we'd add 1 to the 2 in rounding off to 3 decimal places. Here we have 1, 2, 3, 4. So the 4th place is a 9. So you would drop this and add 1 to the 7. Okay. Now, here is a formula for a word problem, and we'll pause while you read it. Well, for something like this, after reading it, for me to try to just read it again to you to explain it, I think they do a good job showing you what's there. Here they're saying E, of course, represents this that you're going to substitute. And using your calculator and asking you to store in your calculator. Now, I don't know whether we'll be having you do that since you're using your online calculators here in the computer or not, but that's what this M is. Memory. You've stored something into memory, and eventually you get this sort of answer. Okay, let's go on to example 6. And looking at the equation they're giving us here, it looks like it's in standard form. So we identify our A as 9, our B as a negative 30, and our C is 25. And they're actually doing that. That might be a good thing. Then you put it into your quadratic formula, solve it carefully, and notice, since what is under the radical turns out to be 0, you only end up with one answer. Now, with one answer like this, an interesting thing is this could actually have been factored. So let me do it for you. 9x squared minus 30x plus 25 equals 0. Because I recognize this as a perfect square trinomial, so basically what you're getting here is 2 of the same. So we get 3x minus 5 equals 0. So we have x equals, we transpose the 5, divide by 3, and that's our answer. So when answers come out like this, you could have factored them. But here you see that the quadratic formula works very well as well. Quadratic formula is good for things that factor and things that don't factor. But factoring is a little easier, I think, if you recognize it. So let's take a look at example 7. And again, it's in standard form. We identify the A as 1, the B as negative 6, the C is 10. We do the substitution carefully, and when we end up with it, we see that x equals this, but under the radical sign, this is not a real number. Now, we kind of skip this, but just for some of you that might recall it from high school, this would eventually be written as 6 plus or minus 2i to make this from a no solution to an imaginary number all over 2. And you could write that separately like that. So that would be 3 plus or minus I is the solution for this equation. Now, don't put that in MATLAB. What you will put in MATLAB is that there's no solution. It's not a real number. It's a complex number. We haven't studied those yet. Okay, well, let's look on to what else they're showing us here. Again, they're giving us lots of material. We're talking about the discriminant. Now, discriminant is something we find under the radical sign. Whatever this becomes tells us the kind and numbers of solutions that we'll get when we use the quadratic formula. And here they're saying if the discriminant is greater than 0, let's say it's 5, 5 is greater than 0, there are going to be 2 real number solutions. After you do this, the discriminant turns out to be greater than 0, then you're going to get 2 real solutions. If the discriminant itself is equal to 0, like we showed here in 1, then there's only going to be 1 real solution. And if the discriminant, this, turns out to be less than 0, such as a -2, there's going to be no real number solutions. So you might get some like this, where they're going to ask you the number and kinds of solutions that you will determine by using the discriminant. It is what is under the radical sign. Okay, now we're looking at some other things in which we use the quadratic equation, and that is right triangles that involve the Pythagorean theorem. Now there's a typical right triangle. There is your right angle right there. And we talk about this leg. That's one of the legs of the right angle is A. That's the short leg usually. Then we have the long leg. And then the angle opposite the right angle, we call that side C. But another name for that is the hypotenuse. Okay? So here they're looking at a TV screen. Let me raise it up a little bit. And by the way, there is the Pythagorean theorem. If you square side A, square side B, add these two together, it is equal to the square of the hypotenuse, or side C. So here we have a hypotenuse that is 46 inches. We have this short leg that's 0.63 of x, and then this side is x. So we want to figure out what is the base here, and perhaps this side. Well, we do so by taking the B side and square it, the A side and square it, and that equals the square of the C side. Ooh, sounds like a poem there. Okay, and the work is all shown, and eventually we reject the negative here, and we get that this side is approximately 38.9 inches, and then we take 63% of that, and that would give you this side. Okay, and there's the work, and again it's a squared plus b squared equals c squared. In this case, since you don't know what this is, you're going to have to fiddle a little bit here. Let's go on. All right, let's take a look at 9. I remember last term I helped someone in Math 1108 do a problem like this. And after reading it, in fact, I made a video. It takes me like 10 minutes to just do this one problem, but I really stretched it out. And let's see what they are going to show us here. Okay, so again, a picture would be very nice. In fact, this is exactly the model of the problem that was in your study plan. We had a shed that was 10 feet and 6 feet. Okay? And we were going to put an area, a border around the shed, and we're wondering how long it should be. Okay, because our overall area was something here. So let's see what they give us. So again, a picture I think is a good idea. There's the information you know, and your new dimensions are out here. And notice that for the overall length of this, it's going to be 10 plus this x plus this x. So 10 plus 2x. And your width is going to be 6 plus this x, and this x is this. So let's see where they go. And we're apparently taking out this inner area here, which is 60 feet. And we want this border to apparently be 36 feet. Okay, this is a little different than the one I did, but it's done in a similar pattern. So we FOIL this, get this, integrate the negative 60, get that, transpose this, and we now have a quadratic equation in standard form. Now to make it easier, we're going to divide everything by 4. We get this, and then this factors nicely. Now when it does factor, we get x equals a negative 9, or x equals a 1. Now, can negative 9 be used in this? And the answer is no. So this is your extraneous root, and our answer is 1. Should be 1 foot wide. That's what the border is. All right, we also use these type of quadratic equations in physical science, where we're throwing an object upward, dropped, or thrown, and we assume a number of things, but this is the formula we end up with. Some of these letters may be a little strange to you. This v sub o is initial velocity, t is time, and HO is the height that we want to get to. And it looks like it's dropped from 625. So H sub O is 625 feet. So a picture might be good here. They didn't give you a picture, but I'll give you one. So there's your building, and you're dropping something off of that building, and you're wondering the amount of time it takes for that item to reach ground level, which is 0. So your initial height, there's the 0, initial height was this, 625, and again it's plugging it in. Now once it's in standard form, you can identify your A, B, and C. Now keep in mind, if you wanted these positive, you could have just multiplied everything by a -1. That would make this positive, this negative. But it doesn't make any difference. You're going to use your calculator to put that in. Now notice when you get your answers, you get two answers. We don't have negative time, so this is your answer. And round to the nearest tenth would be 4.5. To the nearest hundredth, 4.54. Okay? And you have to be careful, because you could have done all of this, and if you don't carefully read the instructions they're giving you to put your answer in, you're going to count it wrong. But again, have your work on a blue sheet. We like to see pictures. We like to see you following the instructions that they're looking for. Okay. Now here in example 11 gets a little tricky, because they're giving you a formula that says V equals this, and they want you to solve that formula for X. So the first thing you must do is recognize that this is a quadratic equation, and you have to put it in standard form. So there it is initially. I'm now going to take the V, transpose the V to the other side, where it becomes a negative V, and there we now have it in standard form. So what is your A? Your A is M. What is your B? There's a 1 there, even though it doesn't appear, a +1. And what is your C? A -V. And that's what they've done. Put it into the quadratic formula, and they solve it for X. And that's what you'll put into MATLAB. Now MATLAB doesn't have a symbol, at least in the ones I've seen, for plus or minus. So you have to write it twice, and you separate your answers by a comma. I've seen students, instead of using a comma, they hit the period button, and they had all the work done, except MATLAB counted it wrong. Again, the teacher should give you full credit for that. That's just a typo. But use a comma to separate your answers. Okay, well, this completes our first chapter in Math 1108. Hopefully these are helpful, but this is like a whole course in some other courses that they're reviewing to prepare you for the next 4 chapters in Math 1108. Good luck to you.